All right, let's take a look at how to do these Lewis structures again. If you remember, the first thing we need to do is figure out how many bonds are going to be needed, and how many pairs of electrons are going to be shared. We're just going to do one of these, but we'll just discuss how to do each of these columns here. So with carbon dioxide, we know that there's one carbon. Carbon would love to have 8 valence electrons. That answer is 8 for almost everything except for hydrogen, which would love to have 2. Boron, which would love to have 6, and beryllium would love to have 4. And then we've got 2 oxygens. It would love to have 8 electrons. I don't know why I put plus sign there. That's going to be equal to 24. Still have one carbon. Carbon's in group 14, so it only has 4 valence electrons. Still 2 oxygens. Oxygen's in group 16, so it has 6 valence electrons. So 6 times 2 is 12, plus 4 is going to give us 16. 16 from 24 is going to give us 8. We need to divide that to figure out how many bonds we're going to have, because there's 8 shared electrons, 2 shared electrons per bond, and that's going to give us 4 bonds. So, trying to figure out who's in the middle. Generally, it's going to be the first thing written. If carbon is there, it's very, 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 very likely that carbon's going to be in the middle. Hydrogen will never be in the middle, remember, because hydrogen only wants 2 electrons, so it'll only make 1 bond. So we're going to put carbon in the middle, put an oxygen on each side, and we need a total of 4 bonds. So we're going to connect everything with single bonds, and now we're going to go back and double them up. Alright, so we're almost done our Lewis structure, except not everything is happy. Only the carbon's happy because it has 4 bonds, 2 electrons per bond, 8 electrons. Each of those oxygens right now only think it has 4 electrons, so we need to add 4 more in the form of 2 pairs of electrons. So our molecular geometry, we need to look at our AXE or ABE. This is going to just be AX2. So our shape, this is linear, straight line. And essentially these pairs of electrons want to get as far away from each other as possible, and the farthest away they can be is a straight line. So that's going to give us a bond angle of 180 degrees. If we have an AX4, or an sp3 hybridization, you're looking at somewhere anywhere between 104.5 to about 109, depending on if we've got 4 bonds, or 3 bonds and a pair of electrons, or 2 bonds and 2 pairs of electrons. For our angles, if we're doing something that's trigonal planar, if it's all in a straight line, we're looking at about 120 degrees per bond, times 3 gives us 180. Any of the weird ones, the expanded octets, those are in your reference booklet, so no need to memorize those. So is it polar or not? Well, what we have to do is look at our difference of electronegativities, and we look to our reference booklet. Let me just see if I've got a reference booklet around here. Found it. The electronegativities for carbon are 2.5. For oxygen, it's 3.5. So our difference of electronegativity is 1.0. So the bond is polar. But that doesn't necessarily mean that the molecule is polar. Remember, we have to figure out, first question, we're going to go down the flow chart. First question, is there a polar bond? Yes. Are there lone pair electrons in our central atom? There are not. Then the next question we ask ourselves, if we answered no to that previous question, is the central atom bound to 2 or more different elements? In this case, it's not. So this is going to be a non-polar molecule. So, because it's nonpolar, none of this doesn't ask us that, but we can think of in terms of what type of intermolecular forces are going on here. In this case, nonpolar means we got London dispersion. For our hybridization, basically we look at our AX notation. We add up our X's and our E's. In this one we only have 2 X's and no E's. So that means we only need 2 orbitals to hybridize. So our first orbital is always going to be an S. There can only be one of them. So the next orbital we jump into is a P. And we could have up to 3 P's. In this case we only need 2. So that 2 here plus whatever we would have for E's, in this case we don't, is going to tell us how many of these we need. Without giving too much away, our AXE for this one would be AX3. I need 3 orbitals. This would be sp2. Down here, this would be AX4. This would be an sp3. So that's kind of what we're doing there.